In this module, we're going to talk about transformations, specifically the log transformation. So if we look at either microarray or sequencing data, in this particular plot, we're looking at RNA-seq data, and we compute the mean across samples and the variance across sample, or the standard deviation across samples, we usually see a relationship like this between the average and the standard deviation. The higher the average, the higher the standard deviation. So we have that for highly expressed genes, we have standard deviations of up to 10,000. While most of the genes that are down here, the standard deviation is only 10. So that brings several problems. One of them is plotting. Notice that this plot is in the log-log plot. If we had made this plot in the original scale, we would have only seen these points out here. Another problem is that simple summary statistics like the average are going to be driven by the variance of these very, very highly expressed genes. To demonstrate that, I calculated these averages for each sample. In this particular data set, we had 10 samples. I computed the average for each sample, and then I computed the maximum for that sample. And you can see how the maximum affects that average. When you compare the sample with the biggest maximum, the average is more than twice as big as the sample that has the smallest maximum. So how can we solve this problem? Well, one simple approach is to take the log. There are other transformations we could consider, but this is the simplest one. So if we take the log of this data and we do the same thing, we compute the average across samples and the standard deviation across samples, now that mean variance relationship is much more flat, which is more desirable. Now we have high expressed genes having about the same variance as most genes. Now we do see a little bit higher variance towards the low expressed genes. There's a reason for that, which we're going to describe in future modules on normalization and background correction. But for now, we will just notice that for the bulk of the data, the mean variance relation is pretty close to flat. So does it get better in terms of the sensitivity to the maximums? Well, yes, it does. So if we take the log and then compute the averages, now the largest maximum is less than twice as big as the smallest maximum. And you can see the difference between not taking the log and taking the log.